Hey, what's going on, everybody? Starting our nice unit on momentum, impulse, momentum change. So here we're going to have some solutions for your initial little practice worksheet, your practice on momentum. So number one, momentum of an object depends on the object's mass and the object's velocity. Because momentum is defined as mass in motion, so it is your mass times your velocity. And momentum is a vector. And we know it's a vector because whenever I draw these little arrows above a letter, that means a vector. Vectors mean that it has direction and magnitude. So knowing that we have direction and magnitude here, we need some complete descriptions of an object's momentum. So if we multiply mass by velocity, we'll get kilograms times meters per second. And we just smash that unit together to get a kilogram meter per second. And it's a vector, so we need direction. So kilograms seconds, that is not it. Kilogram meter per second right, kilogram meter per second west. So B and E work. The rest of them do not, as they either do not have direction to them or they do not have the right unit. So the two quantities needed to calculate an object's momentum are your mass and your velocity. So now if we look at these two objects at right, object A and object B, compared to object B, object A has how much more momentum? We know that momentum is mass times velocity. So object A here has a momentum of 16 kilogram meters per second, and object B is 8 kilogram meters per second. So this has 2 times, so it is choice A. Number 6, we're just calculating some momentum here and including our units. So remember, momentum is mass times velocity. So my momentum will be 2 kilograms times 12 meters per second. So this brick has a momentum of 24 kilogram meters per second. And now for part B, a 3.5 kilogram wagon moving at 1.2 meters per second. Again, we'll define our momentum here as 3.5 kilograms being multiplied by 1.2 meters per second. And that will equal 4.2 kilogram meters per second. Number 7, what velocity must a 0.53 kilogram softball be moving to equal the momentum of a 0.31 kilogram baseball moving at 21 meters per second? So this means, right, that these two momentums need to be the same. So if our two momentums need to be the same, that means that the momentum of the softball will equal the momentum of the baseball. The momentum of the baseball equals 0.31 kilograms being multiplied by 21 meters per second. So the momentum of our baseball, when we calculate this out, will end up being 6.51 kilogram meters per second, which means that that also has to be the momentum of the softball. So now, look at the momentum of the softball, and we know that the momentum of the softball will be that same value. So the momentum of our softball will be the same. So 6.51 kilogram meters per second will then have to equal 0.53 kilograms times our velocity. So when we divide the momentum by the mass, so we divide 6.51 kilogram meters per second by 0.53 kilograms, we're going to get a velocity of this softball to be 12.3 meters per second. 12.3 meters per second. Just going into number 8. In a collision, an object will experience a force acting for a certain amount of time. So a force acting for an amount of time is known as an impulse. An impulse changes the momentum of an object. Change the momentum. So there's sheet 1. It's now on to the back here. A blank causes and is equal to change in momentum. That would be impulse. Impulse causes and is the same thing. It's equal to your change in momentum. So now we want to calculate the impulse experienced by a 65.8 kilogram halfback encountering a 1,025 Newton force for 0.35 seconds. So impulse is the same as your force times your time. So we're given two of these values. We're given 1,025 newtons, and we can multiply that by 0.35 seconds. So then we will get an impulse of 358.75. And our units there are Newton seconds. It's the same thing as a kilogram meter per second. So now we have a tennis ball encountering a force that changes its velocity by a certain value. So remember, our impulse is also the same as your change in momentum. So here, we're given a mass of 0.168 kilograms and a change in velocity of 61.8 meters per second. So this impulse, when we plug this into your handy dandy calculator, you're going to get 10.4 kilogram meters per second. So now we want to start determining impulse and momentum change as this object switches where it's at. So here we've got some pool going on. So to find the initial momentum, we're given a mass and a velocity. So you multiply that mass times your velocity. So we have a momentum of 0.4 kilogram meters per second. So we don't know what the impulse is yet, and we don't know what that change in momentum is yet. But now we have a velocity at the end of 1 meter per second with the same mass. So now our momentum becomes 0.1 kilogram meters per second. Which means that we started at 0.4, we ended at 0.1. So your change is going to be your velocity change from 4 to 1, so we do final minus initial. So our change in momentum is negative 0.3 kilogram meters per second, which is also the same as the impulse. So here we've got a medicine ball with a mass and a velocity, so we multiply those two values together to get 60 kilogram meters per second. We have an impulse of negative 50 Newton seconds, which is the same as your change in momentum. So now we have a change in momentum of negative 50, which means that 60 minus 50, right, we'll have a momentum of 10 kilogram meters per second. And if we have 10 kilogram meters per second for a momentum, and we know our mass is 10 kilograms. If you divide momentum by mass, you will get 1 meter per second for the final velocity. So here we've got a car at rest. If a car is at rest, the car will have 0 momentum, and at the very end it is stopped, so it has 0 momentum. So already we know what two of the momentums are. We're given a force and a time. So if we're given force and time, we can find impulse. So the impulse here is 16,000 Newton seconds, which is also your change in momentum. So suddenly our momentum for part 2 is 16,000 kilogram meters per second. And now more force is applied, so now we have 6,000 newtons being applied for 3 seconds for an impulse of 18,000 Newton seconds, which is also the same as the change in momentum. So now our momentum has changed by 18,000. So we add 18,000 to 16,000 to get 34,000 kilogram meters per second for the third momentum. Well, now we know that our change in momentum, we're going from 34,000 to 0. So we have negative 34,000 kilogram meters per second, which is also the same as your impulse. So if we have negative 34,000, and we know a force of 8,000 newtons, and that would be friction stopping it, so friction would be negative, your time value here will be 4.25 seconds. And out of the last one, here we'll go ahead, start where we know that the ball is stopped, so we have no momentum. And the momentum for part 3, the velocity is 0. So the velocity is 0, there's no momentum. We have an applied force of 60 newtons for 0.1 seconds.
Welcome to Family Feud.
So that means that our impulse is going to be 6 Newton seconds, which will also be our change in momentum, 6 kilogram meters per second. So now our momentum for part 2, when it's moving to the right, is 6 kilogram meters per second. So now we know that our change in momentum will be negative 6, because our final velocity is 0, and we have some initial velocity. So final minus initial is going to give us a negative. So that means that our impulse is also negative 6. Our impulse is negative 6. We'll divide that by the time, which is 0.05 seconds, to give me that the force from the wall is negative 120 newtons. So now we have a velocity of 0. So there was 0. Now we're given a force and a time. So now our force is 120 newtons, acting for 0.04 seconds. So we will get an impulse of 4.8 Newton seconds, which will also be your change in momentum, 4.8 kilogram meters per second. So we go from 0, our change is 4.8, so our momentum for part 4 is 4.8 kilogram meters per second. So there's your nice brief little intro on momentum. Hopefully the sheet went well. If we have questions on it, we'll talk about it on Monday very, very briefly before you guys begin your egg drop. Enjoy the weekend, everybody.